Dear students, this is Dr. Biju Aswad. In this video, we will discuss chapter 9.14 Stokes Theorem. In last video, we might have discussed Green's theorem. Now we discuss Stokes theorem. One more important theorem is there, which is Gauss Divergence Theorem. Right. Now, here we go. Vector form of the Green's theorem has been given here. See, Green's theorem, we know that f dot dr, you remember it, integral over across curve C, f dot dr is equal to double integral qx minus py dA, isn't it? So here we are getting a different version of the Green's theorem, where qx minus py k vector is curl f. So curl f dot k will give you qx minus py. When you find curl f dot k vector, this k vector and this k vector becomes 1, and then you will get qx minus py dA. So this is a different version of Green's theorem in terms of curl f. So that's what we are going to get. That is Stokes theorem. Let S be a piecewise smooth orientable surface bounded by a piecewise smooth simple closed curve C, and f is a function of three variables, which is pi, q, j, r, k. Each and every component is a function of three variables. Be a vector field for which p, q, r are continuous and have continuous first partial derivatives in the region of 3 space containing S. Under all these conditions, if C is traversed in the positive direction, positive is anticlockwise, isn't it? So f dot dr can be evaluated by this one. This is the formula of Stokes theorem. This one is a different version of Green's theorem, which is relating line integral with the area and double integral. Okay, so a line integral along the curve can be replaced by integration over the area if there are multiple curves bounding a region C1, C2, C3 and C4. Instead of evaluating over every curve and adding them up, we can directly evaluate over the region S, isn't it? So that if you know curl of the and the unit normal vector to S in the direction of the orientation of S, it is outward unit normal vector, we call it. If you know these two, we can integrate over the surface. It will be equal. Instead of doing the line integration, we will get double integration. So the formula is curl f dot n vector, this is n vector, ds. ds, we know how to find ds from dx dy. We have the formula for ds. Okay, let's go to the first example. Exercise problem number 1 from the textbook. Verify Stokes theorem. Assume that the surface S is oriented upward. Okay. The function given is f. Immediately write the formula. Integral f dot dr is equal to double integral over surface S curl f dot n cap. We actually should write n cap or n vector, whatever it is, ds. So we have to find a unit normal vector to the surface S. If not given, if n vector is not given, and if the equation of the surface is given, we can derive this one. The n vector is del phi, gradient phi divided by norm of the gradient phi for any scalar function phi. If phi is the surface, use this formula to construct the n vector if not given, right? Okay, let us start here. What is the surface? What we got to do here in problem number 1? F vector S is the portion of the plane Z is equal to 1 is a plane and 3-dimensional, isn't it? This is X and this is Y and this is Z. Z is 1 is a plane going infinitely larger than this. If it is 1 unit height is a bigger plane, infinitely larger. Within the cylinder, the surface, that is the portion of the plane. In this plane we need, this is our surface S, isn't it? Yes. And but this surface is restricted within the cylinder. Cylinder is on the circle is x square plus y square is 4. This is the circle 2, circle of radius 2. This is so the surface above this, within this cylinder, on the z equal to 1, this is the plane z equal to 1. On this plane, within this cylinder, this is our required S actually. This general surface z minus 1, isn't it? So this equation of z equal to 1 is applicable here as well. Now unit normal vector is outward unit normal vector, n vector. You know, for xy plane the perpendicular vector is k. Outward, if this direction it is negative k, but in this direction it is positive k vector. We can verify this one by using this formula. It is possible. So over this surface, S is the portion of this plane within this cylinder. Okay. Now we, instead of, this is F, so we are verifying Stokes theorem. So whenever you are getting the statement verify Stokes theorem, you are supposed to evaluate both the left hand side and the right hand side. The left hand side we need F del F, dr. What is dr? dx I dy j dz k vector. F vector is given here. Therefore, what is F dot dr vector? F dot dr, which is 5y, this F 5y into dx, I dot I will be 1, 5y dx minus 5x dy plus 3 dz. Isn't it? This is the closed integration over the curve. See, the curve is, this is the curve, this is the boundary curve of the surface, which is a circle. Circle which is x square plus y square is equal to 4, which is 2 square. This is the circle boundary of the surface. So instead of evaluating the boundary, we can apply the integration over a surface when it is when the question is to use Stokes theorem. But here we are verifying both the sides. We will evaluate over the boundary and of course over the surface as well. Now, since the circle is left hand, actually we start with left hand side. Left hand side integral over the circle, isn't it? Or circle C. F dot dr. See, over the circle we apply the parametric form of circle, but here only one integration, there is no double integration, so one parameter is enough. So write this equation of circle as x is equal to 2 cosine theta, y is equal to 2 sine theta. Remember, if this is double integral, then you will write the parametric form in two parameters, r and theta, right? Okay, that's what we have done in the previous problem. So here single integral, this limit will be a full circle 0 to pi, only one curve, closed curve, isn't it? 0 to 2 pi, and x will be replaced by 2 cosine theta, y will be replaced by 2 sine theta. What is dx? So what is dx? We will use it. Dx from x. X is, again I am writing x is 2 cosine theta. So dx is 2 minus sine theta minus 2 sine theta d theta, and y is 2 sin theta will give you dy is 2 cosine theta theta. Substitute all the values in this f dot dr and use it here. 5y 2 cosine theta, 5 times 2 cosine theta, isn't it? What is y? 2 sin theta, okay. 2 sin theta, and dx is minus 2 sin theta d theta. The first term is done, dx I mean 5y dx. Next, minus 5 times x is minus x is 2 cosine theta, and dy will be 2 cosine theta d theta. Finally, one more term, 3 times dz, 3 times dz. Okay, what is z given here? Z is equal to 1, so dz will be 0. dz will be 0, third part will be 0. Now we evaluate this problem on the another sheet. Okay, what we have done on the left hand side, integral over c f dot dr. We are finding, we got integral 0 to 2 pi, go back, no, it is 10 sin theta minus 20 sin square theta minus 20 cosine square theta d theta. That's what we got from the previous one. So when you expand this one, minus 20 is constant, keep it outside. 0 to 2 pi sin square plus cosine square, it will be minus 20 is outside, it will be plus, it will be 1 d theta, and integration of d theta will be theta from 0 to 2 pi. This is negative 20. So negative 20 into 2 pi minus 0. So it's negative 40 pi. Left hand side is done. So for the right hand side, we want curl to the right hand. So remember this rule, and right hand side, curl f vector. What is it? I j k dou by dou x dou by dou y dou by dou z. The components of f 5y, the coefficient of I, minus 5x and 3k. Now find the curl. What do you get? I vector times this 2, isn't it? When you differentiate this term with respect to y, it is 0. When you differentiate this term with respect to z, it is 0 minus j vector. Now this term goes with this term, 0 minus this with this, isn't it? Derivation is 0 plus k vector here, this minus 5x derivative with respect to x partially, minus 5 minus so when you differentiate this one with respect to y, it is 5. So the answer is negative 10. K vector is curl. And unit normal vector, you remember, in the surface is given as, I will show you the surface is, we can take phi is z minus 1, because we are given the surface is z equal to 1. Let it be z minus 1 equal to 0. Call this one is the surface. What is the gradient of this one? What is phi xi, phi yj, phi zk, isn't it? And these two components are 0 because there is no x, there is no y. Phi z, when you differentiate with this z, it will be 1. So del phi is equal to k vector and its norm will be 1. Therefore n vector is del phi divided by norm of del phi, which is k vector divided by 1, which is k vector. So we got unit normal vector, which is k vector. Now we got curl f, which is negative 10 times k vector, isn't it? So go and substitute in this formula of Stokes theorem. Double integral over the surface S, we will write curl. So we are finding right hand side. Curl f vector dot n vector ds. Okay. Curl f vector. This is the surface we are dealing with. Curl f is what is it? Negative 10 k vector dot n vector is k vector and ds. Negative 10 is dot k will be 1. Negative 10 is constant. Keep it outside. Double integral over s ds, where s is the surface of the plane inside the cylinder. So it is where s is the surface above the circle. X square plus y square is equal to 2 square on z is equal to 1. So it will be, when you integrate double ds, it will be area of the circle. So minus 10 area of the circle, with circle x square plus y square is 2 square, whose radius is r is 2, isn't it? So minus 10 pi 2 square, pi 2 square. 2 square is 4, negative 10 will be negative 40 pi, just like our left hand side, which is equal to left hand side. So Stokes theorem has been verified for this problem. Let's go to the next problem. Next problem is the case where we use Stokes theorem to evaluate some typological error. Let me complete the statement. To evaluate, assume C is oriented counterclockwise as viewed from the above. Okay, what is this? Let me write. This is nothing but f dot dr single integration over the curve C, f dot CR. That is what I will here. Assume that C is oriented counterclockwise as viewed from above. Okay, this is the question. This is the question given here. F vector is given as this one. This is for F vector. What is Stokes theorem? Integral over C f dot dr is equal to double integral over S curl of F vector dot product with the unit normal vector, outward unit normal vector n, and ds, isn't it? So when we are asked to use Stokes theorem, we use only right hand side. Evaluate it. Instead of finding left hand side, use right hand side. That is it. So we have to find the curl of the F vector and for the given surface, outward unit normal vector What is the surface? How do you find the surface? It's a triangle with C is a triangle. See, this curve is a triangle with vertices 1 0 0 0 1 0 0 0 1 on the xy plane. This is assume that this is 1 0 0 and this is 0 1 0 for y. On z axis 0 0 1. So this is the triangle this is the triangle C given, isn't it? C. There are three curves together. We have to, if you want to integrate over the for the left hand side, you should have three different curves. But now we are directly using the right hand side. So we want curve, and we are going to project this one on the xy plane if necessary to find the limits of ds. Let's check what is good. Okay, now what is the plane? How do you call this? What is the equation of this plane? X intercept is 1, y intercept is 1, z intercept is 1. So x over a, y over b, z over c is equal to 1. This is the equation of the plane that has intercepts as a, b, c. So actually the plane is x plus y plus z is equal to 1. You can write x plus y plus z minus 1 is 0 as your surface function phi. Therefore you can go ahead to find n vector. And on the other hand, we want ds. The formula for ds is square root of 1 plus fx square fy square, isn't it? For which we need a function of xy. So take this equation number 1 right here. Z is take this equation number 1 right here. 1 minus x minus y, which is function of x, y, isn't it? Now fx is equal to minus 1 and fy is also minus 1. So we got, isn't it? When you square it up, it will be 1 1. Therefore what is ds? So times dA. dA, which is 1 plus fx square is negative 1 square is 1 plus 1 into dA. dA is dx dy when you project on the xy plane. So we got somewhat an idea about ds. We will simplify it later. Now find n factorial. Phi is available. For n factorial, the formula is del phi over norm of del phi. So what is del phi? I am finding here del phi. Del phi is phi x I, phi y j, phi z k. So all these terms phi x, when you differentiate this one with respect to x, you get to 1. So I, when you differentiate with respect to y, it will be again 1 j and 1 k. I vector plus j vector plus k vector, that is del phi. Therefore what is the norm? Okay, let's do all this work on the. So remember what is ds and what is ds and what is dA, dx dy. Now we will find it. Okay, now move to the worksheet. Okay, let me recall all the terms. The formula is integral over c f dot dr is double integral over s curl f dot n vector ds, isn't it? And we have a formula for ds is square root of 3 dA. dA we can write dx dy when you have no height, project it on the xy plane, isn't it? So we will write it later on with the limits of xy. And now we have phi x plus y plus z minus 1. Therefore del phi has been found, I j k. What is the norm of this vector? Square root of 1 square plus 1 square plus 1, isn't it? That is square root of 3. Therefore n vector is del phi, gradient of the scalar divided by its norm, which is I vector j vector k vector over square root of 3. This is our n vector, and we have ds. Only thing is to find the curl of the function, curl of the vector f. So find curl now. Curl of f vector is I j k, the function, the coefficient of del. This is actually del cross f, isn't it? Remember it. Dou pi dou x dou by dou y dou by dou z. Now the components of the vector are 2z plus x, y minus z, ex plus y, isn't it? Now as usual the derivations cross for I vector, which is 1 minus 1 minus j vector. For j vector, this with this one is into 1 minus z, this one minus 2 plus k vector, this and this. There is no x, so 0. There is no y, so 0. So 0 minus 0. So what is curl of? Simplify this one. 2 1 plus 1 2I minus plus j. This is curl f. So we have almost all terms that we need for this formula. Curl f, we have n vector, we have ds formula. And remember, the next page I will recall the tetrahedron. This is like this, isn't it? This distance is 1 unit, this distance is 1 unit, because this point is 1 comma 0 comma 0 0 1 0. This is 0 0 1. So when there is no z, you fall on this triangle. So this is your xy, this is x, this is y. So it will have a graph like this, 1 unit here, 1 unit here, isn't it? So here, if you consider dx dy or dy dx, this is actually what is, when you integrate over this one, you are finding the area of this. When I write double integral ds over s, this is the formula of area of this triangle. The formula of area triangle is half. You can still go ahead with the finding horizontal strip or vertical strip, but the easiest method is half. Height is 1 unit, breadth is 1 unit, so half into 1 into 1, isn't it? That should be remembered. Now let's be back to the right hand side. We are just applying the right hand side. Double integral curl f is 2I plus j dot n vector. N vector is I vector plus j vector plus k vector over root 3, and ds is actually square root of 3 dA. Okay, this root 3 and root 3 can be cancelled. Double integral, find the dot product. Dot product of two vectors. The first vector k bar is 0, so that will be 0. I dot to this one will be 2 plus 1 3. And this root 3 will be cancelled. dA can be x on the xy plane, dx dy, so which is 3 times dx dy. We can write 3 as, because we are on the triangle, this is area of the triangle OAB. What is it? 3 into half into 1 into 1, so 3 by 2. The answer is 3 over 2. The next problem we will see the PowerPoint. Answer can be found here. A different curve. So again we are using Stokes theorem. That's it again. So what is Stokes theorem? Integral over C f dot dr is equal to double integral or s curl f vector dot n vector ds. As usual, ds can be found on this xy. We can do it. Okay. First we will find curl f, and then we will find n cap by finding the surface. Surface is given here. This is the surface. Z is equal to 9 minus y square. So we will write z minus 9 plus y square is equal to 0, which is our phi, isn't it? And what else? When you take this z is a function of y, we can get f and find ds. That is also possible. So f of x y, a function of two variables z, is equal to 9 minus y square. So from this one, this is equation number 1, this is equation number 2. What else? F dot r, we will come back to those parts later. First we'll find curl f vector I, j, k. The components are x square. So here dou by dou x, dou over dou y, and dou over dou z. First component is x square y. Second component is x plus y square. X plus y square. Third component is x y square z. So use the procedure I is to, when you are just use these two. When you differentiate this one with respect to y, you find 2x y z minus derivation of this with respect to z is 0 minus j vector, this with differentiate this one with respect to x, y square z minus differentiate this term with respect to z, it will be 0. It will be 0 plus k vector is k vector times what? This 2, isn't it? This 2. So first differentiate this one with respect to x, you will get 1 plus 0 is constant, the y square is constant, so 1. And differentiate this one with respect to y, you get minus x square. Therefore curl f vector is 2xyz I vector minus y square j z j vector plus 1 minus x square k vector. So curl f is ready to apply in this formula. The curl f is ready. Now we got to find ds and n vector. ds and n vector. What is the formula for ds? Square root of 1 plus fx square fy square, which is the equation of the surface. Z is equal to, isn't it, a function of xy. So from this one, what is fx? From equation number 1, there is no x, so 0. What is fy? Minus 2y minus 2y. Therefore, ds will be square root of 1 plus 0 plus 4y square dA. Actually, there will be a dA here, isn't it? This dA can be dx dy. We are going to project on the xy plane. So when there is no z, this surface you will fall here. This will be your base, isn't it? Which will be a surface on the xy plane, like y is equal to 2x and y is equal to 3. Y is equal to 3, y is equal to 2x. You get this triangle on the xy plane. So on this xy plane, we will choose either type 1 or type 2 or any other method we are comfortable with. We will use it later on. Now we will find n by using equation number 2. We will find n vector. What is the gradient of pi? Pi x I, pi y j, derivative of pi with respect to x partially, into I, dou pi by dou y times j, dou pi by dou z times k vector. Differentiate this one with respect to x. What do you get? What is the pi x? Pi x is 0. There is no, so pi x is 0. Pi y is 2y. Pi z is 1. So what is del pi? This time is 0. 2y j plus k. Therefore, what is the norm of del pi? Square root of 2y square, 2y whole square, 4y square plus 1. That is okay. Then what is n vector? Gradient of pi divided by its norm. So what is gradient of pi? It's given here 2yj. So n vector is 2yj vector plus k vector divided by square root of 1 plus 4y square. You see, n vector we got unit normal, outward unit normal vector to the surface given here, and ds is already available here. Now use all the curl f is available here, all information in this equation, the first formula, isn't it? So we are going to substitute all these terms in the integral and then finish this problem. And the xy will be calculated from this one. Okay, we will be back to we will write it later on. So remember, this will be the circle, triangle on the xy plane, where this y is equal to 2x, y equal to 3, both are taken from the given graph. Okay, we will continue it on our sheet. Okay, now if the right hand side, we are using it in the Stokes theorem, so right hand side is curl f dot n vector ds. What is curl f? Minus 2y cube curl f dot. I found the dot product of curl f and n vector. Check dot product of these two here, divided by square root of 1 plus 4y square, and ds is square root of 1 plus 4y square dA. So it will be double integral negative 2y cube z plus 1 minus x square into dA. You can write dx dy. So the limit we have considered, this is the triangle we got. This is y is equal to 2x and this line is y is equal to 3. So when we want to integrate with respect to x first, we need to take a horizontal strip, isn't it? Horizontal strip. So lower limit is 0, upper limit is x is equal to y over 2. X is equal to y over 2. So 0 to y over 2. And this strip should move in this direction from 0 to 3 for y. So that's the limits of y. Now we have to integrate, that's all. When now we integrate it, outer limit is 0 to 3 for y, inner integration with respect to x. Integrate it. What do you get? Minus 2y cube z x plus x minus x cube over 3 from 0 to y over 2, and y is outside, dy is outside. Substitute upper and lower limit. Lower limit is 0, so no term will be there. Upper limit 0 to 3 minus minus 2 y cube z x is y over 2 plus y over 2 minus y cube over 8 into 3 is 24 dy. Further simplification will give 0 to 3, this 2 and this 2 can be cancelled, minus y raised to this z is the variable, should be converted now. This z remains here, and we know in this problem given z is equal to 9 minus y square, the equation of the surface. You remember it, that will be replaced here, minus 2y, here it will be minus y raised to 4 into z is 9 minus y square. If z involves x, we should have introduced it earlier. Since there is no x, we are introducing it right now. Okay, 9 minus y square plus y over 2 minus y cube over 24 into dy. The next page we will simplify, multiply this everywhere inside. We will write integral 0 to 3 minus 9y raised to 4 plus y raised to 6 plus y over 2 minus y cube over 24 dy. Integration is done, then it will be negative 9y raised to 5 over 5 y raised to 7 over 7 y square over 2 minus y raised to 4 over 4 times 24 96, and the lower limit upper limits are 0 to 3. Substitute them, you will get minus 9 over 5 243 plus 1 over 7 y raised to 5 3 raised to 7 will be 2187, y square will be 9 over 4. This is actually 4. Y square over 2 is 2 into 2 will be 4 minus 81 over 96. When you simplify all this one, you look at negative 123.57. That will be the end of the problem. The textbook is given as positive, you write this negative actually. That's the end of this problem, and this concludes this chapter. The next chapter, divergence theorem, will be discussed in the next video. Thank you very much.